Hello everyone, thank you for joining us for the webinar today. My name is Ben Hutchins and I'm part of the marketing team here at Autodesk Innovise. Today we are proud to be hosting this webinar in partnership with British Water on the topic of the British Water How-To Guide applying the SuDS Manual C753. If you have any questions as we run through the slides today, please type them into the question box located in the right corner of your GoToWebinar interface. We won't mention your full name when reading your questions, and our experts will provide answers. Please also note that all phone lines are muted during the webinar today. Now let me introduce you to your experts. Firstly, we are delighted to be joined by Joe Bradley, Operations Director at Stormwater Shepherds. Joe has worked in the field of pollution prevention for over 30 years and is passionate about getting the water quality elements of SuDS design right. She enjoys looking for opportunities to deliver water treatment devices into SuDS management trains that both prevent pollution and allow the ponds and wetlands to become excellent habitats for nature. Joe joined Stormwater Shepherds in September 2020 and is intent on reducing plastic pollution, both from plastic litter in towns and cities and from microplastic tyre wear particles in road runoff. Joining Joe is Dr. Ma Batista. Ma is responsible for the strategic oversight of British Water's UK technical and international programme. Ma specialised in agricultural engineering and was awarded a doctorate in environmental science and sustainable water management. Ma has an excellent understanding of current water and environmental challenges due to her significant experience in running British Water's technical focus groups and Secretariat for BIM for Water and the Grease Contractors Association. She is passionate about connecting people and ideas towards a sustainable future. Next, we have Dr. David Smoker. David has over 35 years experience in the water industry and is a technical director at ACO Water Management, where he champions developments in surface water management and environmental issues. He sits on various industry technical committees and British and European standards committees concerned with the SuDS and surface water management. He is chair of the British Plastics Federation Surface Water Management Group and is director of the Future Water Association. We're also pleased to welcome Daniel Jarman. Daniel is Hydro International's Group Technical Manager. He joined the company following a PhD on urban drainage with the University of Exeter and has worked with the company for over 15 years. He is responsible within the company for managing research collaborations and product development efforts leading to new products, setting product specifications and design protocols, product compliance, and oversight of the company's intellectual property portfolio. Finally, your host today is Jessica Jeffries. Jessica is Product Manager for Drainage Design at Autodesk Innovise, looking after our industry-leading drainage design products and engaging with a large multidisciplinary customer base. Jessica is actively involved in several industry bodies and has a keen interest in promoting surface water management. So that completes our expert lineup for you today. So let's start the show. Jess, over to you.
Thank you very much, Ben. So first, just a quick poll. If Ben, you can get that going. Just want to see where we've got people joining from today before we get into the main body of the webinar. So you should see popped up now the poll, what is the nature of your organisation? So local authorities, water companies, consultants, developers or other. So we'll just leave that up there for a minute or two before we move on to the presentations. As you heard from Ben, we've got a great list of presenters joining us today. Some of those are authors of the how-to guide. Ma Batista representing British Water, and the good news is we will have plenty of time for a Q&A at the end where you can quiz everyone on that. Okay, if we can close the poll. And great to see people from all the categories joined, mostly consultants, as we would usually expect. So we will hopefully be able to enlighten you on the British Water how-to guide as we go forward. Okay. think we can close that now and go back to the slides. So a little bit on the agenda first. As Ben has introduced, we've got several of the authors on the call, as well as Mar Batista from British Water. And we also have to thank Stuart Ramella of Polypipe for his contributions to the how-to guide, and Bridget Woods-Ballard, Steve Wilson and Mark Goodyear for their valuable input as reviewers of the guide as well. It was great to work with all these people on this project, and they really are experts in this field. So first up, you are going to hear from Daniel Jarman. He'll introduce the how-to guide, applying the SuDS Manual C753, simple index approach to proprietary and manufactured stormwater treatment devices. Not the snappy title, but definitely plenty of detail in there from Daniel on the guide itself. Joe's going to cover some more practical applications of the guide, how it relates to designing SuDS solutions and sort of surface water solutions as a whole. And then, as we've mentioned, we've got David Smoker and Mar joining us for the Q&A at the end. So before I hand over to Dan, I just wanted to put a reminder up of where you can download this guide. If you go to the British Water webpage and the publications section, it's right at the top there at the moment to download. We can make sure that that link goes out with the follow-up after the webinar, where we send the recording as well. Okay, I am going to hand over to Dan now and give Dan control of the slides.
Thanks, Jess. Am I coming through?
Yes.
Thank you very much. Hello and good afternoon, everyone. Ben and Jess have already given the introduction, so I'll just thank them for that and move on to the main content of the webinar, which is this webinar and Q&A session on the how-to guide for applying the SuDS simple index approach to manufactured stormwater treatment devices. So this is a new guidance document that was developed by the British Water Surface Water Management Group and launched around a month ago. And you can see the other contributors that have been involved with this effort on the left-hand side of the slide. So in a nutshell, the British Water Group have developed a document set and process that plugs a couple of information gaps in the SuDS manual and allows practitioners to use proprietary treatment systems as part of a SuDS treatment train when using the simple index approach. The documents provide a common basis for the selection of SuDS components, and really with the aim to bring manufactured treatment systems onto a level playing field with the information available for other SuDS components that are already listed in the SuDS manual. So the aim of today's webinar is to introduce the documents and the process that the British Water team have developed and not get too much into the design detail and small print, but if there's appetite for a more technical session, we can gauge that at the end of today's session. So in today's webinar, we'll be covering what proprietary treatment systems are, what the British Water Code of Practice and how-to guide cover and where to find them, which Jess has already kindly presented, the SuDS manual and the simple index approach, the process for deriving mitigation indices for manufactured or proprietary systems, the outputs of this process and the generated supporting information. Joe will then present a few design examples and we'll move on to the Q&A session. So firstly, what do we mean by proprietary or manufactured treatment systems? Well, originally these were categorized purely as subsurfaced and pipe systems, and that's still a common feature, but there are more and more systems that are surface-based or blurring the lines between these zones. Typically, surface-based systems are of course favored, but subsurface systems can be preferable where there are additional design constraints or site constraints related to health and safety or space. And it can allow developments to meet other design objectives related to amenity, biodiversity, or quantity control. Now, what you can see here on the slide is a range of images of different proprietary systems, and depending on how you view life, you might say they become more complex the further down the page you go. But commonly or generally, proprietary systems apply a combination of different treatment approaches, and these are screening out of larger debris, settling of dense particulate material or sediments, flotation of free-phase oils and trash, flotation of smaller particles or neutrally buoyant material, sorption of dissolved pollutants like heavy metals and nutrients, and bioremediation or biotransformation. And this is where microorganisms or biological processes metabolize or capture pollutants to reduce their long-term impact. But generally, the primary focus is on removing sediments and solid material. Sediments and solids are either directly polluting or toxic themselves, or they provide a large surface area for the dissolved pollutants to bind to. So sediments tend to carry the greatest pollutant load and pose the greatest environmental hazard. Proprietary systems come in a number of shapes, forms, and such as treatment chambers, drainage channels, or planters, and this is really so they can accept runoff and flows and rainfall in a number of different ways. So the question is, what can these systems do, and how do I appropriately design them into a SuDS scheme? And that nicely leads us into the design processes laid out in the SuDS manual and the supporting documents produced by the British Water Group. So British Water has launched 2 documents relating to applying the simple index approach to manufactured stormwater treatment systems, and these are shown on the slide and the links at the bottom. The main gap we're addressing with both of these is the derivation of pollution mitigation indices for use in the simple index approach. And I will give more detail and it'll become apparent what that is as we go through the presentation. The first document on the list is the British Water Code of Practice for Assessment of Manufactured Treatment Devices, and that was launched back in 2016. This is a voluntary lab test protocol to generate supporting data for the derivation of mitigation indices for manufactured devices. Now, the tests entailed in this are based on elements of the US New Jersey Department of Environmental Protection and the German DIBT test protocols. But the tests adopted have been adjusted to ensure that they are suitable for UK conditions. The second document on the slide is the how-to guide, which was launched just a month ago. This adds the additional information required to derive a full set of mitigation indices for a manufactured system, and it also presents the scientific justification behind this. Now, our original aspiration with the how-to guide was to have a document that was, say, half a dozen pages long and easily digestible. But once you factor in all of the design questions and handling of test data from different sources, we've ended up at a document of around 60 pages, and that covers a comparison of prevalent test protocols for manufactured systems, a range of design examples for selection and sizing of manufactured systems, derivation of the mitigation indices, comparison of the mitigation indices against field data, and how to map tested mitigation indices to a range of product sizes. Now, the main audience for these documents will be manufacturers undertaking testing and actually deriving SIA mitigation indices for their systems. But it contains sufficient information for designers, local authorities, and other approval bodies to understand and scrutinize the design processes for designing SuDS, including proprietary systems. Now, most importantly, both of these documents have been reviewed by SIRIA and the authors of the SuDS manual to ensure the approaches presented are in keeping with the SuDS manual and scientifically robust. So moving on to the design processes laid out in the SuDS manual. Now, I would hope all of the attendees are familiar with the SuDS manual, but for those of you wondering what on earth a mitigation index is and why you should care, we'll go through a bit of an introduction to set the scene. The SuDS manual is a very comprehensive guidance document published by SIRIA. The underpinning philosophy is there are 4 aspects or 4 pillars which are pivotal to the design of SuDS schemes. And these are water quantity, water quality, amenity, and biodiversity. The SuDS manual, of course, contains many answers and where available has robust supporting evidence for its design processes. Now, although it's a guidance document, many aspects of the design principles are now regularly seen in local planning requirements, so you're seeing a lot of the guidance become mandatory. Now, the only downside is this document is around 1,000 pages long, so we will need to restrict our focus today to the chapter on design principles for water quality, and more specifically, the simple index approach. So that lands us in chapter 26 of the SuDS Manual, which is water quality design methods. And table 1 in this chapter is reproduced on the left-hand side of the slide, and it details 4 different assessment methods or design methods of varying complexity for addressing water quality. And the complexity varies depending on the pollution hazards present and the sensitivity of the receiving water body. So the lower the environmental risk, the less complexity is required and the less effort is required in the design process. And this is to make designers' lives as easy as possible. So the simplest method is aptly named the simple index approach, or the SIA method for short. And this is what the documents published by British Water support. Table 4.3 back in chapter 4, which is designing for water quality, gives guidance and examples on where each of these 4 design methods is applicable. And this table is shown on the right-hand side of this slide. So between these 2 tables, you can determine the appropriate design approach for your development. For low to medium risk developments, the simple index approach is applicable with a couple of caveats. Examples of low hazard developments would be residential properties and low trafficked roads or car parks, such as those for schools and offices. Medium risk sites would be more highly trafficked zones, such as commercial yards, hospitals, retail parks, and any other road, excluding trunk roads and motorways. Now, I mentioned a caveat in applying the SIA method. For medium hazard sites with discharges to groundwater, the risk screening approach must be applied to determine whether the SIA method remains appropriate. And this is essentially an additional risk assessment that was developed by Highways that quantifies additional detail about the traffic density and risks to groundwater. If you do that risk assessment and the risk remains low, then we continue using the SIA method. I'll point out the SIA method is not appropriate for high hazard scenarios, but these would include scenarios like trunk roads and motorways, and also industrial, chemical, fuel handling, waste management, and manufacturing sites. Today, we are only interested in covering the SIA method, and this is expected to apply in the vast majority of SuDS design cases. So moving on to the SIA design process itself. Now, this is a bit of a busy slide, but it's the minimum content required to give a bit of a crash course in the simple index approach. So bear with me and I'll talk you through an example. The SIA design process takes a source pathway receptor approach. So it quantifies what hazard a particular site or source presents, and it requires that the pathway provide mechanisms to give acceptable pollutant levels by the time the flow reaches the receiving water body, which is the receptor. Now, in the SIA process, 3 pollutants are considered, and they are TSS, total suspended solids, metals, and hydrocarbons. A value named the pollutant mitigation index is used to rank and select SuDS components that reduce hazards to an acceptable level. So if we run through a quick example of this, step 1 is to allocate an appropriate hazard index for the site, and these are contained in table 26.2. Taking the case of a residential development, which is low risk, we have pollution hazard indices of 0.5, 0.4, and 0.4 for TSS, metals, and hydrocarbons respectively. Step 2 is to select SuDS with suitable pollution mitigation indices that meet or exceed those hazard indices. And the mitigation indices are contained in table 26.3 on the right-hand side of the slide. From this, we can see there are actually multiple SuDS elements that would meet our requirements, but a filter strip or swale would be adequate in this scenario. The only additional point to note here that if a single SuDS feature cannot meet the required mitigation index, then you can actually chain multiple SuDS features together in series, and the mitigation indices summed up to provide an adequate value. However, for a downstream SuDS feature, the mitigation index is actually multiplied by a factor of 0.5, so it's only considered half as effective. And this is to account for the lower inflow concentrations of pollutants into that downstream component. And step 3 is to consider a more precautionary approach where the receiving water body may be sensitive or protected. And this is largely due to the fact that the SIA method is relatively simple, and it makes a general assumption on the sensitivity of the receiving water body, but that's broadly okay for low or medium risk scenarios. Now, the difficulty that we as manufacturers face, or the manufacturers face, is that table 26.3 contains mitigation indices for green or natural systems, but not for manufactured and proprietary systems. So this is the gap we're bridging with the documents published by British Water. And I will just touch on where the mitigation indices for the greener systems come from, as it's relevant to understanding what they represent and what we need to establish for proprietary systems. So the mitigation indices are an indicator of average annual load reduction of a particular pollutant. And these have been derived from a project called the US BMP, or Best Management Practice Database, and that's recently been retitled the International Stormwater BMP Database. This project monitored over 700 sites around the US to establish the efficacy of different SuDS components. And a summary of the findings is actually found in the SuDS Manual as table 26.13, and it's reproduced on the left-hand side of this slide. Now, we don't need to go into this in too much detail, but I'll give an example of how you arrive at a mitigation index. So for a detention basin, the measured TSS inflow interquartile range is between 20 and 114 milligrams a litre, and the output is between 10 and 47. So you're getting around a 50% reduction in TSS between the inlet and the outlet. The mitigation index given in table 26.3 for a detention basin is about 0.5, so it corresponds to that value, and I hope that gives a bit of traceability about where these mitigation indices come from. Now, manufactured systems were included in the USBMP project, which aimed to categorize them by the general treatment approaches they applied. However, the mechanisms that each manufacturer is applying in their product is quite specific. And due to this, the SuDS manual actually just sets a requirement that the mitigation indices must be declared by the manufacturer. So if we jump and look at that requirement in a bit more detail for proprietary systems, which is shown on the bottom of table 26.3 in the SuDS manual, the requirement states proprietary systems must demonstrate they can address each of the contaminant types to acceptable levels for frequent events up to approximately the 1-year return period event for inflow concentrations relevant to the contributing drainage area. Now, that is a bit of a mouthful, but what it's essentially left manufacturers and proprietary systems required to do is quantify and demonstrate annual pollutant inflow and removal rates for TSS, metals and hydrocarbons up to the annual treatment flow rate. And this requirement is of course aimed at giving a value that is equivalent to the mitigation indices already found in table 26.3 for the green systems. So in response to this requirement, the British Water Group has developed a standardized and robust approach for the derivation of mitigation indices. So the first step in this process is laboratory testing to establish pollutant removal rates. The test procedures themselves are outlined in the Code of Practice published by British Water, and the diagrams are taken on the slide here, are taken directly from this document. The TSS removal is tested at full scale, and the dissolved metals removal is tested down at a 1% scale sample of the filter media. And the reason for using a small scale setup for dissolved metal is really to avoid the need for handling large volumes of contaminated water, which of course pose an environmental risk in itself. the removal of hydrocarbons is not tested or not covered in the code of practice. If there is significant risk of hydrocarbons or spill events, then designers should be referring to PPG3 and using EN 858 certified systems. Further information on deriving a hydrocarbon mitigation index for a manufactured device is contained in the how-to guide, which we'll get to in a moment. What you can see from the code of practice test setups is they look similar despite the scale. And what we're really doing is controlling the flow rates and inflow concentrations, and then measuring the output concentrations to determine the pollutant load reduction for that device. And I'll just touch on the flow rates we use for the testing, because this is where we have placed a lot of the effort in ensuring the code of practice and how-to guide are representative of UK conditions. Now, broadly speaking, urban pollutant loads and sediment distributions don't vary that much between Western countries with temperate climates, but what does vary a fair amount is the rainfall distribution. So to ensure the design and testing procedures that are relevant to UK conditions, we've derived the test flow rates directly from UK rainfall data. So we took EA rain gauge data for 7 cities and we processed these to determine the rainfall volume contributions related to the variation in rainfall intensity. And what we found is, while there's some variation, when you average these out over a number of years, they're quite similar across the whole of England. And there's actually very little difference in the peak intensity. Now, that means we can effectively use one set of test flow rates and one distribution, and it's suitable for all regions, which makes life a bit simpler. And this analysis was undertaken by HR Wallingford and Cranfield University. Now, there's a lot of, there's a graph on the slide, but the number we're most interested in as manufacturers and designers is the treatment flow rate the device must be able to handle, as this generally dictates the size and the cost of the system. And here the magic number is a rainfall intensity of 27 millimeters an hour, which accounts for around 99% of annual rainfall volume. And this corresponds to a runoff from an impermeable surface of 75 litres a second per hectare. And that's to say, if you have an impermeable area of 1 hectare, you're going to need a device with a treatment flow rate of 75 litres a second. Now, one additional caveat here is the system must also be able to safely pass the 1 in 30-year peak event without causing flooding. This requirement is laid out in both the SuDS Manual and the Design Construction Guidance for sewers. This flow rate is not tested. The device is not expected to provide treatment under this condition, but it would put constraints on whether a system can be designed in an offline or online configuration. So we've spoken about the testing. Moving on to how these test results feed into the how-to guide and are used to derive mitigation indices. The how-to guide gives procedures for deriving mitigation indices for multiple recognized SuDS assessment protocols. So it can accept test results from the British Water Code of Practice, the New Jersey Department of Environmental Protection Testing, or the German DIBT test procedures. Now, unfortunately, none of these test procedures give a complete set of data for deriving mitigation indices. The how-to guide is there to fill in the gaps and provide calculations to give a complete set of mitigation indices and make sure that the test values are adjusted appropriately for UK conditions. So if we take the route of the British Water Code of Practice testing as an example, the Code of Practice only presents lab tests for quantifying annual load reduction of TSS and dissolved metals. Hydrocarbons and the solid phase of heavy metals is absent. Now, the how-to guide then explains how these values are populated to arrive at a full set of mitigation indices for TSS metals and hydrocarbons. There's no pass or fail in this process. It effectively allows manufacturers to declare any or prove any mitigation index value. So it gives flexibility to both manufacturers and designers to target what suits their needs. And the outputs of this assessment process are 3 documents. The first will be a test report according to the British Water Code of Practice or other equivalent test protocol that we've discussed. And this will of course be signed off by the test house performing the testing. But that typically only focuses on assessment of a single unit size. And this is where the second document and the how-to guide are relevant. The second document is a declaration of a full set of mitigation indices and the flow capacities or drained areas for a range of unit sizes in a product range, if they exist. And the third document we're recommending is an independent verification statement. And this is effectively a desk check to ensure the mitigation indices and flow rates have been derived correctly. And this should be signed off by an appropriate independent consultant. Now, we've taken this route because British Water is not a certifier or a regulator, but of course, completion of the full process allows manufacturers to demonstrate that their published mitigation indices are appropriately evidenced and derived in accordance with the requirements set out in the SuDS Manual. And that, of course, translates into any planning constraints derived from the SuDS Manual. So at the moment, British Water is in the process of setting up a website to house these output documents listed on the previous slide. And this will be a repository of supporting information for designers and SuDS approvers. And the aim of that is so they don't have to go hunting around through several manufacturers' websites and they can very clearly see what's been through this process. And you don't need to be a British Water member to contribute or access this list. And finally, my final slide before I hand over to Joe. In acknowledgement that no process or guidance is perfect, we've set up another web page to capture any clarifications or questions that need addressing as various parties undertake the testing. And this is to really capture and close off any difficulties or loopholes and ensure that there's a consistent approach for all parties. Now, when this is sufficiently populated, of course, we can use it to update and revise the British Water documents. And that concludes my part of the webinar, and I'll hand over to Joe for a few applied design examples.
Thanks, Dan. That was brilliant. A number of times I sit through that presentation of yours and I still learn something every time. So what I'm going to talk about is the practical application of the mitigation indices. So you are a manufacturer or you're a designer, the mitigation indices are coming out onto the market, and I'll talk a little bit here about how you might apply them and use them in your designs. Or I would if I stopped muting myself. Bear with me. Oh. Important not to forget that the how-to guide and the British Water Test Protocol both say the following methods make the assumption that the principles and design protocols set out in the SuDS Manual have been followed. So regardless of the work that we're doing here and the mitigation indices for manufactured devices that we're talking about, you must remember that you've got to take the whole picture of SuDS design as described in the SuDS Manual. So do that master planning, look at your topography, look at your infiltration capabilities, understand how much water you need to attenuate. All that has to be done as well. This is not a standalone piece of work. It's part of the whole SuDS design picture. So just a couple of examples. This is a swale, which I guess you're all familiar with. This is a swale in a place called Chorley in Lancashire. And I'm just going to show you how you would apply the simple index approach to a swale. And then we'll go on and talk about how that now moves forward to include manufactured treatment devices following the publication of the how-to guide. So this swale like I say, is in Chorley, so it's a well-designed swale because it has over the edge drainage, so the runoff from the road comes over the edge, down that grassy incline and into the conveyance channel at the bottom of the swale. So the pollutants are caught up in the grass, they soak into the soil, they're broken down by the sunshine and the microorganisms. So an excellent SuDS device. In the SuDS manual, as Dan has just explained, there are mitigation indices provided for a swale like that, and you can see them in column 1. So the mitigation indices are 0.5 for TSS, 0.6 for metals, and 0.6 for hydrocarbons. So that is the mitigation available from that swale according to the SuDS manual. So the hazard indices for a low risk site are 0.5, 0.4, 0.4. So that swale on its own satisfies the requirements for water quality design for that swale and for that surface, rather, that urban surface on its own. You just need that swale if you've got a low risk site. But a medium risk site, which you can see in the right hand column, that has a pollution hazard indices of 0.7, 0.6, 0.7. So the swale on its own isn't good enough. It doesn't give you enough mitigation to mitigate the pollution from that urban surface if it's a medium risk urban surface. So that's how the simple index approach works in practice for a vegetative treatment device. The next device to look at is a pond, because I like ponds. This pond is also in Chorley and it's very, very beautiful. It creates a really lovely habitat for wildlife in the summer, and it does all the pollution control that we want it to do. So applying the simple index approach to a pond like that, again, in the first column, you can see the mitigation indices taken from the SuDS manual, 0.7, 0.7, 0.5. And for a low risk urban surface, your hazard indices are 0.5, 0.4, 0.4. So that pond on its own delivers all the water quality improvements that you need. So for a low risk surface, you've done your water quality requirements. For a medium risk surface, you've got a problem with hydrocarbons. So your hazard indices are 0.7, 0.6, 0.7, and you haven't quite got enough mitigation for the hydrocarbon element of the runoff from a medium risk urban surface in that pond. But the SuDS manual says all ponds should have a sediment capture device upstream, because that prevents the pond from filling up with sediment and pollutants. So if you do a SuDS management train, as Dan has just suggested, then you would have 2 sets of mitigation indices, and you would easily achieve the hazard indices, mitigation indices required to meet the hazard indices for that medium risk site. So SuDS management trains give you that opportunity to have better mitigation in your SuDS management train by having 2 or 3 devices. So this is where manufactured devices come in, and this is why we did the British Water Test Protocol and the how-to guide, because it allows you to incorporate these devices into your design. So they become part of what you might call hybrid SuDS. So you might have a manufactured device and then you might have a vegetative device, and you marry up the 2 sets of mitigation indices to give you the water quality improvements that you need. So same table. So in that first column, you've got the mitigation indices, and they are now provided by the manufacturer. So these mitigation indices are precisely what have been derived using the how-to guide by the manufacturer. And if you speak to the manufacturer of a vortex grit separator, they will give you mitigation indices. So an example set here of 0.5, 0.5, 0.7. Different manufacturers will have different results depending on their test results. But for a low risk site, that means that those mitigation indices for that vortex grit separator satisfy the water quality requirements of SuDS design. So for a low risk site, you just need that vortex grit separator, job done. For a medium risk site, your pollution hazard indices are too high at 0.7, 0.6, 0.7, so your vortex grit separator on its own isn't good enough. But, remember, that doesn't matter, because you must remember that you have to deliver all 4 pillars of SuDS. So today we're focused on the water quality aspects of a SuDS design, and this device will give you compliance with your water quality aspects of your SuDS design for a low risk site, but you still need to do water quantity, biodiversity and amenity. So you still need to deliver attenuation and a habitat for wildlife and pleasing places for people in your SuDS design. So you have to have other devices built in and around the vortex grit separator to deliver those multiple benefits. So you can start to see that you are building up a SuDS management train that's delivering all the requirements of the SuDS manual, but doing it using a variety of devices. This is one of the examples. This is a vortex grit separator discharging to a pond. And as Dan has said earlier, remember that if you have a setup like this, a management train like this, you can use the mitigation indices for your vortex grit separator provided by the manufacturer, and then only half of the mitigation indices delivered by your pond, which come from the SuDS manual. So you'll see in a minute that actually when you start to do these SuDS management trains, you start to deliver very, very high quality water quality improvements by having different devices in series. And then the other really, really important thing to think about is the treatment flow rates. So this is something that we spend a lot of time talking about in the British Water meetings, and it's important as designers that this is something you give some attention to. You need to understand how your device is working in your SuDS management train and how much of the runoff it's treating. So Dan's explained that you need to treat 75 litres per second per hectare for a low or medium risk site, but you probably have to convey more than that when it rains hard. So you have to understand how your device is going to cope in a normal rain event, a subannual rainfall event, but also what's going to happen when it rains really, really hard. Where's all the water going to go, and is it going to whoosh the pollutants out of the device? So work out what you're using, work out what your treatment flow rate is, and then work out what the capability is of your SuDS management train. So some devices like a filter can't tolerate huge flows because the filter will bung up, so you may want to put those offline. Some devices like a pond are designed to increase in volume when it rains hard and then allow some of that water to escape under a in a controlled way. But you need to make sure that those things are happening and the treatment is not being affected by those hydraulic actions. So as we've said, 75 litres per second per hectare for low and medium risk surfaces, that's what you have to treat. But remember, for high risk surfaces, I know we're not focusing on high risk surfaces today, but you do need to think that if you're designing SuDS management trains for high risk surfaces, you need to understand where the water will go when it rains hard, bearing in mind that that water will still be polluted. So as we've said, some devices work really well, but they can only cope with little flows. So you put those offline and blend that runoff back. So when we're looking at high risk surface design for water quality treatment, sometimes we'll treat a little bit of the runoff very, very well. So we might remove 90% of the pollution in that little bit of runoff and then blend it back with the rest of the runoff to give us a total reduction that we need. So high risk surfaces are more complex, and you really, really need to understand what's going on with your water quality and your water quantity and how they're interacting with one another. So a couple of examples, and please note that these numbers are for illustration only. These are not specific mitigation indices for any of these specific products. They're just illustrative. So you might have in your SuDS management train, you might have a vortex grit separator at the top of the system to capture the suspended solids and the associated pollutants. You might then have a stormwater filter to capture a particular pollutant like dissolved metals, and then you might have a pond for polishing and removing some of the organic pollutants and removing more of the suspended solids. So you can start to see with the mitigation indices there that we're building a really, really good water quality treatment train. So we've got 0.5, 0.5, 0.7 from the vortex grit separator, and then we get half of the mitigation indices for the filter, so 0.4, 0.4, 0.35, and then half again for the pond, 0.35, 0.35, 0.25. So you're starting to build a really, really good SuDS management train there, dealing with all the different pollutants, dealing with different processes for pollution control, and giving you a really excellent improvements in water quality. Things to think about at the bottom, your vortex grit separator will usually take all the flows off the catchment, and the high flows will simply bypass through the top of the system. Stormwater filters I prefer to see offline because they, although hydraulically they can take higher flows, I prefer to see them offline so there's no risk of washing the filter material and damaging the filter material. And then ponds very often take all the flows, fill up when it rains hard, and the level of the water lowers after the rain event has passed. So one example of the sort of thing you can see in a SuDS management trend that's really good. And then other items, so we haven't talked about spillage risk, but if you can have a oil water separator, if you've got a combination of spillage risk and pollution risk. And again, a device like that, that's a bypass oil water separator, really good mitigation indices, 0.8, 0.6, 0.9, but it only treats the treatment flow rate that's declared by the manufacturer, and higher flow rates will bypass through the top of the system. And modular bioremediation zones are quite new to market, and they treat quite a small flow rate, but they treat it to a high level. So again, you can start to see that you can build a SuDS treatment train using devices like this to give you really excellent water quality improvements. High-risk surfaces, I won't labour the point because we're running out of time, but please remember a couple of things. Spillage risk is more common on a high-risk surface, and also the need for closure devices. So sometimes your SuDS management train will do an excellent job, but you need a closure device at the bottom in case there's a massive spill on the catchment. So if you have a catchment where there's a risk of spillages, and those spillages would cause pollution, it's good to have an automatic closure device either upstream of your pond or downstream of your pond to protect the water environment from that spillage. And you need to think about treatment flow rates in greater detail for high-risk surfaces. And please remember to consider groundwater protection, particularly on high-risk surfaces. We talk about infiltration a lot with SuDS, but just infiltrate with care, please. And the way you put them is important. Sediment removal devices at the top of the system, wherever possible, because if you can get the sediment out first, that protects all your downstream devices. And actually the sediment wants to drop out as soon as the flow slows down. So have your sediment removal device at the top of the system. Stormwater filters should be at the bottom of the system if possible, because the cleaner the water before it goes through the filter, the better, the more of that dissolved pollution you will remove. And then spillage containment devices upstream of vegetative devices so that we don't contaminate the pond we've built. That photograph I showed you of the pond in Chorley is a beautiful habitat for wildlife, and it would be a crying shame if there was a massive oil spill that went into it. So think about that. Don't create habitats for wildlife and then pollute them. And whatever you do, whatever you build, whatever you design, please make sure that there is a maintenance plan and maintenance money in place. This is a photograph from a colleague of mine of an oil water separator that is full and is ready to be emptied. It may have been ready to be emptied some time ago, but it's done a magnificent job of catching all that nasty, polluting, poisonous sludge. It's our job to make sure that's then taken away and disposed of accordingly. Don't build brilliant SuDS and then not look after them. Thank you very much.
Thanks for that, Jo and Dan. Okay, we've got a few questions come in, so I'm going to get everyone to turn their videos on, if that's okay, on our panel. I'm also going to just stop sharing the presentation for a minute, which hopefully means you will all see our videos. No, it doesn't look like it. Can you see our... Someone can just pop in the chat whether you can see our webcams or not. That would be helpful. Great. Okay. So thanks again, as I said, for that really good summary of the guide and also some details on how to apply it. We've got a question come in about water companies, first of all. So should all water companies be following this guidance? Some water companies list proprietary treatment systems under their as not a preferred option due to the maintenance demand. So I'm not sure who the best person is to take that, but anyone want to make a comment about water companies?
Sometimes it's least said sooner it's mended, I think, in that respect. No, I mean it's quite complicated in a lot of ways, because the codes for adoption of sewers now includes Part C, which includes SuDS, which does include proprietary devices and manufactured devices as well. It's up to the water and sewer companies, whether they do adopt or not. That's another issue which is going forward. And in the background, we've also got the government review of DEFRA's review of whether Schedule 3 is implemented or not, or whether we carry on with the situation we've got at the current time. So should they be following it? My view is yes. Will they be following it? That's a more open question.
think, David, it's fair to say that if they choose to accept manufactured devices, then they should take the mitigation indices that are declared by the manufacturer. I agree with some of them choose to and some of them choose not to, but if they choose to, they should take the indices from the manufacturer.
Yeah.
Great, thanks for that. And then a question about Scotland. So would Scottish testing be required before this resource can be applied in Scotland? Dan, you spoke about the rainfall. From memory, that didn't include Scotland. Any further comments?
It didn't include any Scottish rainfall in the analysis. I don't see why there couldn't be additional verification just to check that the test flow rates were appropriate, but I wouldn't expect there to be that much difference. Not when you're looking at the sort of peak annual behaviour. I can understand that the extreme peaks might be different.
Mm-hmm.
But, there might need an additional verification step for Scotland or SEPA.
Yeah, from memory, the graph with the curves on for the rainfall showed that there wasn't a huge amount of variation across England. So, as you say, you'd expect for those flow curves that it wouldn't be entirely different in Scotland. Okay, so next question. When, Joe, you were giving an example which included a stormwater bypassing a treatment device, I think it was talking about the filtration device, how could you say that that meets the pollution indices if some of the flow is actually bypassing?
Okay, so for some high-risk surfaces, we'll blend. So we might say that for a particular high-risk surface, we need to remove 50% of the copper in the runoff to protect the water environment. So we might treat a portion of the flow to remove 90% of the copper and then blend that back with the other part of the flow to achieve 50% removal in the whole runoff, but only by treating some of it. Does that make sense? So it's just a question of treating some of the runoff very well and blending that back with the rest of the runoff. If you don't do that, then you can never achieve that fantastic quality treatment in all the flow. You just can't filter, certainly not much above 100 litres per second. So if you've got a motorway discharge with 700 litres per second in a 1 in 1 year rainfall event, or 900 litres per second for a 1 in 1 year rainfall event, which is really feasible, then treat some of it very well and blend it back to give you the overall requirement for the mitigation indices.
Yeah, and I think the safety factor there is that there's this concept of initial runoff being more concentrated than when you get a higher degree of rainfall, a high level of rainfall, because you wash off the surface with the initial rainfall, and then the rest is less polluted. So there's a safety factor there.
Great, thanks for that. A question on checking the technical submissions, so whether approving authorities would be capable of checking technical submissions. I guess, Dan, you touched on who might use the guidance to produce the mitigation indices. Any further thoughts from you or anyone else about how approving authorities might then consume the outputs of this guide?
I would think that you're consuming the mitigation indices in your design, but you probably want a verification letter in your project file or approval submission. I would think that would suffice.
Yeah,
typically from a capable consultant.
David,
yeah, typically from a capable consultant. I mean, we've deliberately not specified any particular entity because it is, if you use the how-to guide, it's clearly set out there for a consultant to actually say, right, this is the process that's being followed through. And yeah, I agree with the way that the manufacturers calculated their mitigation index.
Sorry, I was considering from the project rather than the device, but yes, I mean,
yeah, absolutely, yeah.
To name a few, WRC, HR Wallingford, any consultant in the water realm.
Yeah.
Yeah, great. And I guess also those, as you mentioned, the intention is that once a certificate or an approval letter has been gained, that British Water are happy to put those on the website, not being a reviewer themselves, but the onus still being on the designer to essentially check that they are happy with those certificates. Thanks. Okay, next question. Can these mitigation indices be applied to road gullies? Any thoughts there? I don't know if there are any proprietary manufactured road gullies that would provide treatment.
There are lots of road gullies. They
yeah.
haven't been tested. They don't fit into the scope of any of the test regimes we've talked about. Road gullies are a bit of a nightmare. Road gullies, if they are operated beautifully, can work very well. But that would mean emptying them before every rain event. So they capture the sediment, and they do quite a good job of capturing sediment, and some of them can capture 40 or 50 litres of sediment. But if you don't take that out before it rains hard, it just whooshes off into the river. So I wouldn't give you, I'm sorry, but I wouldn't give you a mitigation index for a gully pot. But if they are managed beautifully, they do deliver water quality improvements. Does that make sense? Somebody else chip in.
No, it does, and I mean you're absolutely right, and it comes back round to this maintenance aspect as well. You know, that anything, whether it's a manufactured device or whether it's a natural device, a natural SuDS component, does require regular maintenance for it to operate in the way that it's designed to operate.
If I was designing a road scheme today, I wouldn't have gully pots. I'd have SuDS. I'd probably have filter drains, because those of you who know me know how much I love a filter drain. But if you have to have pipe drainage, then use gully chutes or pipe drainage and take that drainage to a vortex separator or an oil water separator, where the sediment can be captured with a declared mitigation index and emptied easily and off network. That process of having to empty gully pots one after the other on a busy road is a nightmare. It's a maintenance nightmare. It's a traffic management nightmare. Much better to take your runoff off the road, off network, and stick it through a big device that has been tested and measured.
Thanks, Jo and David, for that. So a question on nutrient enrichment. Do you see that would ever be incorporated into the mitigation indices?
Who wants to go for that? I think it's more a question of the SuDS manual first.
Yeah.
Have to be driven from the main guidance.
Anna, what's the situation with testing for nutrients in America? Do they have published tests for nutrient capture like they do for
There
sediment?
are a few different states where they assess nutrient removal, phosphorus and nitrogen.
Nitrates, yeah.
It's obviously the low-hanging fruit first, isn't it? What is most damaging? And then you go down the list. I suppose in the UK, they're probably not as highly prioritized as heavy metals.
Although that's changed, doesn't it, with the nutrient neutrality rules from Natural England. And I know Natural England are writing guidance at the moment on the ability of SuDS to capture nutrients. So it's not mitigation indices, it's more of a guidance document. So I think that the next iteration of the SuDS manual, I'm saying this in a very, I don't think Louise is on the call from Syria, so she'll probably shout at me, but I'd like to see the next iteration of the SuDS manual include a much bigger focus on nutrients. And as you say, Dan, that might then drive a whole new system of this work, where we then write a test protocol for nutrient capture, and then a how-to guide for creating mitigation indices for nutrients. We've obviously got to do.
Yeah, good point. We know that Syria are doing some work on potentially looking at gaps in the SuDS manual, and we know also that nutrients are on their radar, but actually how that comes together and what happens, I think, is still to be decided. Okay, another question on SuDS and maintenance. Usually up to the council to maintain them. However, councils, the comment here is councils take their time maintaining these things. oh, sorry, it takes their time. So is there a potential business initiative for private contractors to be in charge of maintenance? Any thoughts from the panel on that?
Absolutely.
I would.
Yes, what you've got to remember is that not all SuDS will be adopted by the local authority. In fact, quite a lot of them aren't adoptable by the local authority. And so there'll be the responsibility of the owners of that particular piece of land, which may be a housing association or a residents association or something of that ilk. And sure, you know, that a lot of them won't want to take on the maintenance of SuDS features, whether they're green, natural, or whether they're proprietary themselves, and they want to put it out to a management company, maintenance company. So,
there are lots of international models as well, David, where the whole stormwater management role is taken on by a stormwater management entity that's paid for by homeowners, and they do the whole shebang. They do the installation, management, operation. So that would be lovely if we had that in this country. So yes, stormwater. Have a look at some of the international models of stormwater management. They're good.
Okay, thanks for that. I've just noticed we are at 2 o'clock. I'm going to sneak in 2 last questions that I think are a quick, 2 quick yes/no questions. Should this information be included in an FRA? Flood risk assessment, I assume that stands for.
Yeah. I think, does it not go the other way, that you would do the flood risk assessment and that would feed into the surface water management plan?
I think that would be my expectation, that at the flood risk assessment level, you wouldn't necessarily know which devices, even which SuDS elements are going to be included. Okay, and any thoughts on whether 2 elements in a SuDS train can be the same? Can you have 2 swales in series?
Oh, certainly you can physically. I'm not clear what that does in terms of the mitigation indices and this, whether the second one becomes half or whether it's a continuation of the first one.
I mean, 2 chances to capture is still 2 chances to capture.
Yeah.
However, it doesn't seem like money well spent is probably what I'd say.
Yeah. I mean, if you had 2 swales in series, is it 1 swale or is it 2 half swales?
I think it's more complicated for swales because they take over the edge drainage, so they theoretically can't be in series. But 2 ponds in series is lovely if you've got the room for it, but don't forget you can only have half your mitigation indices for your second pond.
Yeah.
You've got loads of space, Naomi, you go for it.
Good questions. Okay, sorry that we've run out of time. We haven't got through all the questions. We will look at those and get our panel to help us get back to you with answers to some of those where we can. I'd like to thank our speakers today and the panel for joining us, Joe Bradley, David Smoker, Daniel Jarman and Mar Batista, and thanks to British Water for allowing us to run this webinar again. I hope you've all enjoyed it. I think we've got a final slide just to share that we have further water talks coming. Next week, one on improving river health in 2022 and beyond. And if you'd like more information on our training courses or any of our pre-recorded webinars, do check out our website. Thanks again.